Hello, this is Tyagarajan. In this video, I am going to discuss how to answer for multiple choice questions in computer architecture and organization. If you have not subscribed to my channel, please press subscribe button and also click on the bell icon and choose the option all. If you want to get the questions in PDF form, go to description. The link has been given. In this video, I am going to discuss some of the important instructions from the MIPS instruction set with basics and what type of questions may be asked from this topic and how to answer for such questions. There are 5 types of instructions in MIPS instruction set: arithmetic instructions, logical instructions, data transfer instructions, conditional instructions, and unconditional instructions. You have to remember some of the instructions under each type, and you should clearly understand how these instructions work. The simple example for arithmetic instruction is add $S1, $S2, $S3. In this case, the contents of S2 register will be added with the contents of S3 register and the result will be stored in S1 register. Similarly, in the case of subtract instruction, sub $S1, $S2, $S3. In this case, S2 minus S3 will be computed and the result will be stored in S1. Then add immediate. Add immediate means there will be 2 registers and 1 immediate data. So in this case, the contents of S2 register will be added with value 20, that is data 20, and the result will be stored in S1 register. The next one is subtract immediate $S1, $S2, 20. In this case, S2 minus 20 will be computed and the result will be stored in register S1. In the case of multiplication, MUL, multiply $T1, $T0, 25. In this case, T0 will be multiplied with 25 and the result will be stored in T1. The next instruction is divide div $T1, $T0, 4. In this case, T0 will be divided by 4 and the result will be stored in T1. The next type of instructions are logical instructions. The best example is AND $S1, $S2, $S3. Here, the contents of S2 will be ANDed with the contents of S3 and the result will be stored in the register S1. Then AND immediate means the contents of $S2 will be ANDed with immediate data 20 and the result will be stored in S1 register. You can use any register here, not only S1 and S2. Then another instruction is OR. OR $S1, $S2, $S3. In this case, the contents of S2 will be ORed with contents of S3 and the result will be stored in S1. Then shift right logical $S1, $S2, 10. In this case, the contents of register S2 will be shifted right by 10 bits and the result will be stored in register S1. Shift left logical. In this case, the contents of S2 is shifted left by 10 bits and the result will be stored in S1. The next one is data transfer instruction. Load word $S1, 20 within brackets $S2. So in the data transfer instructions, the value directly given in the instruction is an address. So the contents of S2 will be added with this immediate value 20. This will give an address. This address will point a memory location. From that memory, 4 bytes will be taken and those 4 bytes will be stored in S1. Similarly, store word $S1, $20 S2. Here the contents of S2 will be added with 20. This will give an address, and the contents of S1 will be stored in the memory location pointed by this address. So in the case of store word, the contents of register will be stored in the memory. In the case of load word, the contents of memory will be stored in the register. The next type of instructions is conditional instructions. Example is branch equal $S1, $S2, $25. In this case, the contents of register S1 will be compared with the contents of S2. If both are equal, then the program will jump to the program counter value plus 4 plus 25 into 4. It will jump to that address and start to execute from there. In the case of unconditional instructions, jump 2500. It is 2500 is giving address. It is combined in a special way with the program counter to give the address of the instruction. Now let us see what type of questions can be asked from this instruction set. For the following C statement, what is the corresponding MIPS assembly code? Assume that the variables f and h are assigned to the registers $S0 and $T0 respectively. The C statement is f is equal to h minus 5. Any variable in the C statement can be represented by a register in MIPS language. H is represented by register T0 and F is represented by register S0. Now let us see the options. A. Subtract immediate $T0, $S0, 5. Option B is subtract immediate $S0, $T0, 5. C is subtract $S0, $T0, 5. D is subtract $T0, $S0, 5. Here the value 5 is an immediate value. So you have to use only subtract immediate instruction. So options C and D are not valid here. So it may be either A or B. Now you see what you have to subtract. You have to subtract H minus 5. Here H is represented by T0. So in the subtract immediate instruction, T0 should be the second operand. So if you take the option B, subtract immediate $S0, $T0, 5. In this case, T0 minus 5 will be computed where T0 is nothing but H. So H minus 5 is computed here and the result will be stored in S0. S0 is nothing but F. So option B is the correct answer. Now let us see the next one. The instructions which copy data from the memory to microprocessor registers and vice versa are called as register memory instructions, data transfer instructions, C. Direct memory instructions, D. Data manipulation instructions. In this case, the data is transferred from memory to register and register to memory. So it is a data transfer instruction. So option B is the correct answer. Now let us see the next question. Load and store instructions are used to perform memory operation, register operation, both, none. Here option A is memory operation. If in any data transfer instruction memory is involved, then it is memory operation. In load and store instructions, both memory and registers are used. But register operation is used if data are transferred between two registers. So here option A is the correct one. That is, load and store instructions are used to perform memory operation. So the next one is return instruction. A puts the return address register RA value in PC, program counter. Puts RA plus 4 value in PC. Puts PC plus 4 value in RA? None of the above. The answer is A. Puts the return address register value in program counter. Because when the processor executes the function and returns to the main program, it gets the return address from RA, and to continue the execution, it puts the RA value in program counter. Now let us see the next one. Match the following. Load word, branch not equal, jump, shift left logical. These are given in the left side of the table, and in the right side, unconditional branch operation, data transfer operation, logical operation, conditional branch operations are given. Now let us see the options. A, 1, 3, like that they are matching. B, C, D. There are 4 options. If you see the first one, load word, it is a data transfer operation. So 1 in the left side will match with 2 in the right side. So 1, 2. If you see the options A, B, C, D, A is matched with 1 and 3. 1 and 2 is matched only with B and C. So A and D will not be correct. So it may be either B or C. To fix the correct answer, you see the next one, that is branch not equal. You know that branch not equal is conditional branch operation because it is a conditional instruction. So 2 is matched with 4. So in B, 2 is matched with 1, but in C, 2 is matched with 4. So by fixing the 2 items in the left side to the right side, you will be able to identify the correct answer. The correct answer is C. Now let us verify the third and fourth items, that is J 2500. It is unconditional branch operation. So 3 is matched with 1. You see in C, 3 is matched with 1, and finally 4 is matched with 3. That is shift left logical is logical operation. So C is the correct answer. If you like this video, please press like button and also share the link with your friends. If you want to get the questions in PDF form, go to description. The link has been given. Don't forget to subscribe this channel.